Fifth grade Excel, lesson 115, calculating the mean, median, and mode using stem and leaf plots. All right, let's go ahead and get started here. I'm going to read this part to you just to cut to the chase. Calculating an average produces a number that can be used to describe a set of information. The one average number is intended to represent all the data. I think they have a wrong word in there. There are three methods for calculating an average. The method to be used depends on the data to be evaluated. The three methods are mean, median, and mode. All right, let's talk about the difference between mean, median, and mode. First of all, the mean. The mean is the most useful when the data is all within a relatively narrow range. It is calculated by adding all the values in the set and dividing by the number in the set. This is traditionally what we call an average. Okay, now, I know this is all kind of probably a little confusing to you at this point. Let me try to make it a little more clear. If you have a bunch of numbers that are in some data, so let's say we've recorded all of the test scores for some tests that you've taken, and we have an 80 and a 70 and a 60 and a 50 and a 75 and a 76 and an 81 and a 68. Okay, these numbers are all within kind of a pretty close range. None of the numbers are like way lower than the other numbers or way higher than the others. Like if we had 100 in here, that would be a lot higher than the 80 or 81, which is the highest number. Or if we had like a 35, that would be a lot lower. And so when the numbers all fall within a pretty close range of each other like this, you want to find the mean of those numbers to represent what those numbers are about, approximately what they all are, okay? So if we want to know how this kid is doing on the test, the average or the mean would be an appropriate thing to find. Now we move on to the median. It says the median is most useful when some of the points of the data deviate a lot from the bulk of information. I'll explain that to you in a second. It is calculated by putting the values in order from least to greatest and then selecting the one value in the middle of the set. Okay, median is, let's just talk about how you find it first of all. You take all the numbers, let's say we've got 60, 70, 80, 90, and 100. All right, the median is the number that's in the middle of that set. Notice I line these up in order from little to big. You can also put them from big to little, doesn't make any difference, but you pick the number that's in the middle. That's the median. Now, when would we want to find the median instead of the average for a set of numbers? Let's go back to the example that I gave you over here. If we had this where this one number is just way out of whack from where the other ones are, the median would be in a more appropriate number to represent how that student is doing on the tests. Because if we find the average, this one number down here is going to suck their average way lower than they probably deserve, because all these other test scores they've done pretty well on. They're all about in the 70s or so, right around in there. And yet a 35, that's just a crazy low number. It's going to pull their average way down. And so if you find the average in that situation, it doesn't really represent how that student is doing very well. All right, let's go to the last one, the mode. The mode is most useful when some values occur more than once in a set of data. It is calculated by selecting the value that occurs most often in the set. If no numbers repeat, there is no mode. So mode is a number that I would see repeated. In this set of data, these test scores here, there is no mode because none of these numbers repeat. 60, 70, 80, 90, 100. But let's say you got 60, 70, 70, 70, and 100. Well, the mode would be 70 because you can see I've got a bunch of 70s in there. That one's real easy to find. You're just looking for the number that you see most often. And once again, sometimes there is no mode. And the time that you'd want to find a mode is in a set of data where one of the numbers repeats quite a bit. All right, if that's confusing to you, you might want to pull back the scroll bar there, watch that part again because there's a lot of information in there before you move on. The following are the 10 test results for each of a set of 3 students. If all the scores are added for each student, the total is 870. Therefore, all 3 have the same mean or the same average, all right, so which is 87. So what they're telling you is all 3 of these kids, if you add up all their numbers for each one, you are going to get 870. They've already done that math for you. And if they took 10 tests, remember to find a mean or an average, you divide by the number of numbers, which means they each have an average or a mean of 87. All right? But what about mode and median? What is the median for each student? If there is no one value, you select the 2 in the middle, add them together, and divide by 2 to get the median. In other words, you find the average of the 2 middle numbers. Or another way of looking at it is you find the number that's in between the 2 numbers that are in the middle. Well, we're going to go ahead and do these together. They're a little bit tricky. So if you think you know how to do it, you can always pause the video, try it, and then turn it on to see how I did it. But these are a little bit on the hard side. Number 1, Chandra. The median, the way I do these is I cross off one number from each end. That's 1, 2, 3 crossed off, 4, and then the 2 middle numbers here are both 86s. So the middle number, right between 86 and 86 in a sense, is still 86. Margie, I'm going to cross off 1 on each end. Remember, we're looking for the middle number. Middle number here, both 92s, so the median is a 92. 1, 2, 3, 4. Now here we have 86 and 100. What's the middle number? The middle number comes right in between 86 and 100. The way you do that is you add up 100 plus 86, which is obviously 186. Divide that by 2, which is going to be 93. Half of 18 is 9, half of 6 is 3. So Frank, the median for him is 93. 93 is the middle number, even though it doesn't exist in the list. Make sure you have all this written on your paper before you go on. All right, now what about the mode for each score? That's the number we see most often. You should be able to do that one real easily. Why don't you pause the video, do 4, 5, and 6, find the number that occurs most often in these lists. If there is no mode, then you write no. So you're going to write right here, yes, or you're going to write no. If you write yes, write what the mode is. If you write no, you're done. Okay, either yes or no on the first blank. Go ahead and pause the video, do those, and turn it back on when you're ready for the solution. All right, so for Chandra, we have an 85, 2 85s, 2 86s, and 2 92s. So there's no winning number. There's no mode for that set. Margie, we have a couple of 88s, a couple of 92s, a couple of 94s, and a couple of 99s. There is no mode. Frank, we have 85, 85, we have, look at all those hundreds. 100 is obviously the most popular number, so the answer is yes, there's a mode, and 100 is that mode. And then the last part, this is some of the trickiest stuff. This is probably the trickiest question of the whole year of Excel, so don't get too frustrated on this. It says, which method of averaging would you use to best describe the data for each student? What they want to know is for Chandra, would you use mean, median, or mode to best tell how Chandra is doing on the test? What about Margie, and what about Frank? What I'd like you to do is pause the video, go back and look at the descriptions from the very beginning that tell you when you want to use those, and then see if you can come up with the right answer. If you can solve these, you're doing awesome. Pause the video, turn it back on when you're ready for the solution. All right, so for Chandra, Chandra has a bunch of scores that come really close to each other. They start at 83, they go to 92. There's no crazy low or crazy high numbers. So the mean would be a good one for her. Obviously, mode is not a good one. She doesn't even have a mode. Now Margie. Margie has a number that's really low and out of whack with the rest of the numbers. So the median would make the most sense for telling how Margie is doing on her test. And obviously, again, mode is not going to work for Margie because she has no mode. And then Frank, he's got a mode, and he's got a lot in our 100 right there. And so mode would make the most sense to describe how Frank is doing on the test. All right, another way to arrange the information is by developing a stem and leaf plot. This type of graph can be used where there is a wide range in the data. Suppose you need to collect data on the ages of people who bought a particular magazine. You might stand at the checkout counter of a grocery store, and every time someone bought that magazine, you could ask them their age. Of course, they'd probably punch you if you did that, but anyway, at the end of the day, you would have a list of the ages of the people like this. Here are all their ages, all the people that you asked, how old they were as they bought that magazine. Notice that all the numbers are just all messed up. There's just like all different numbers all over the place. You could then make a graph. The digit in the tens place of the age goes in the stem column. The digit of the ones place goes in the leaves column. The leaves should be arranged from least to greatest. And so what you end up with is a graph that looks like this. This means tens place, and that's ones place. So this is the number 12. Let's see, is there a 12? Here it is, right here. That number 12 is represented right there. This represents the number 14. This would be 18. You can see there are two 18s in your data. Answer this question, Ori. What number would this one right here be? Okay, you should have said 33. What number would that one right there represent? You should say 44. How about this one right here? What number is that? That would be 58. And again, you can figure that out because this is the tens place, 58. So each one of these little numbers across here represent one person and their age. And it's all organized from the lowest number up to the highest number. Okay, and it tells you right here, more people in their 20s than any other age bought this magazine. People of the ages 40, 43, 44, and 48 bought the magazine. That's what those numbers mean. And only one person over 60 bought the magazine. This graph shows that more people in their 20s bought the magazine than any other age group. What could we do if we wanted to determine this is an accurate representation of the buyers of this product and not a mistake or a coincidence? Okay, read that question again, pause the video, turn it back on when you're ready to see the solution to that answer. Go ahead and just write it down here below what you're thinking about that, okay? All right, I went ahead and paused the video and wrote down my answer. I said that we could do the study again at a different store, and that way we'd find out if our data here was pretty accurate. If we got the same results at another store, we could probably feel pretty good about it. And of course, most of you that are watching this video, you already have a song that helps you remember all this mean, mode, median stuff. I'm going to go ahead and play it for you right now. Make sure you're listening to your mean, mode, median song because that's going to help you to keep it straight in your mind, the difference between mean, mode, and median. So rock out to mean, mode, median.